students, you are welcome to physics class. Previously we've been discussing the properties of waves, ranging from reflection to refraction to superposition and diffraction. But today we are going to be looking at total internal reflection. And when we are talking about total internal reflection, we are talking about that reflection of the incident ray of light when light travels from a dense medium to a less dense medium. And when that happens, the angle of incidence in the dense medium is always greater than the critical angle. Remember in our discussion on refraction, I told you that refraction simply means the change in the direction of light as light travels from one medium to another medium. Or simply put, you can say that refraction is the bending of light. So when light is bending as it enters from one medium to another medium, it's called refraction. But total internal reflection, like I said, is the reflection of the incident ray of light when light travels from a dense medium to a less dense medium. And when you're talking about a medium being dense, it simply means that medium is heavier than the other medium that it is being compared with. So the media under consideration in this topic are the glass, the water, and the air. And it is an indisputable fact that the glass is heavier than the water, and the water in turn is heavier than the air. So when you're talking about the dense medium here, we are talking about the glass being more dense than the water and the water being more dense than the air. So the conditions for total internal reflection to occur are as follows. We have two major conditions for that phenomenon of total internal reflection to occur. And the two major conditions are: one, light must be traveling from a more dense medium to a less dense medium. That is to say, light must travel from either water to air, or from glass to water, or from glass to air. If the reverse is the case, then the phenomenon of total internal reflection will not occur. Then the second condition for that total internal reflection to occur is that the angle of incidence in the dense medium must be greater than the critical angle. The angle of incidence in the dense medium must be greater than the critical angle. And somebody will be asking, what is a critical angle? The critical angle is the angle of incidence in the dense medium when the angle of refraction is less dense, in the less dense medium, is 90 degrees. I repeat, the angle of incidence in the dense medium when the angle of refraction in the less dense medium is 90 degrees. Now I'll be giving you a video or showing you a video of how this total internal reflection occurs. So be patient while I show you that particular video, the practical explanation of total internal reflection and how the incident angle is always greater than the angle of refraction. So hold on while I show you that video.
Let us consider a ray of light passing from glass to air, that is, from a denser medium to a rarer medium. When a ray of light is incident on a refracting surface, a major part of the incident light is refracted and a small portion is reflected. The refracted ray bends away from the normal after refraction. That is, the angle of refraction R is greater than the angle of incidence I. Now, if we increase the angle of incidence, the angle of refraction also increases. And for a certain angle of incidence, say IC, the refracted ray grazes over the surface of separation and the angle of refraction will be 90 degrees. IC is referred to as the critical angle. Critical angle is that angle of incidence for which a ray of light, while moving from a denser to a rarer medium, just grazes over the surface of separation of the two media. That is, the angle of refraction is equal to 90 degrees. If we further increase the angle of incidence, the light ray, instead of getting refracted, bounces back into the same medium, obeying the laws of reflection. This is known as total internal reflection. Conditions to be satisfied for total internal reflection to take place are: the ray of light must travel from a denser medium to a rarer medium. The angle of incidence must be greater than the critical angle for those two media.